In this question, we'll use the Rydberg equation. The question asks, if an electron in a hydrogen atom starts at n equals 4 and falls to n equals 1, is this emission or absorption? What is the wavelength? And what is the frequency? We use the Rydberg equation if an electron moves between levels. For our particular atom this time, we'll have n equals 1, which will be close to the nucleus, and n equals 4, which will be further away from the nucleus. We're starting from n equals 4 and falling to n equals 1. Anytime an electron changes levels, the Rydberg equation will tell you the wavelength of the photon that is either emitted or absorbed while this happens. Anytime an electron moves, it either releases energy or it takes in energy. Now, if the electron falls in level, that is, if its level goes down, that means it will release energy or emit energy. This is called an emission. In order to go up any amount of levels, we have to take energy in. This is called an absorption. Now, since we started from a high level and went down to a low level, this tells us our level went down, and what we've done is an emission. Now, to find the wavelength of this, we'll use the Rydberg equation. The equation goes like this. We'll say wavelength raised to the negative first power is equal to r times 1 over n final squared minus 1 over n initial squared. As usual, lambda stands for wavelength. Notice that it is raised to the negative first power. This will be important in a moment. R is the Rydeberg Constant. It is always going to be 1.097 times 10 to the 7th power, and the unit is a little unusual. It is inverse meters. This matches the power that we wrote on wavelength. Now, n final is our ending energy level. Now we can see the way the arrow points in this picture that I've drawn that we're going to end on n equals 1. Now, Ni, or N initial, was our starting energy level. Again, we can see from our picture that we started from level 4. So we'll say N initial is N equals 4. So we know R and we know both levels. Let's fill those numbers in. R was 1.097 times 10 to the 7th. Multiply by 1 over n final. N final was 1 squared, minus 1 over n initial, which was 4, also squared. If we take these parentheses and take 1 over 1 squared and subtract 1 over 4 squared, we will end up with 15 over 16. Now we'll need to multiply the 1.097 times 10 to the 7th times 15 over 16. We'll end up with 1.028 times 10 to the 7th is equal to wavelength to the negative first. Now, to remove the negative first, you can take a negative 1 power on both sides. So, we'll take our wavelength to the negative first and then raise it to the negative first power again. We'll also take our number from the right side, 1.028 times 10 to the 7th, and raise that also to the negative first power. The negative 1 and negative 1 on the wavelength will cancel out. And so our answer is 1.028 times 10 to the 7th, the quantity raised to the negative first power. When we place this into a calculator, we'll get 9.723 times 10 to the negative 8th power, and our answer will come out in meters. This will be the wavelength of the photon that gets emitted as the electron falls from level 4 to level 1. Now for part C, to find the frequency of that photon. Now we found that our wavelength is 9.723 times 10 to the negative 8th meters. And recall that the speed of light is equal to wavelength times frequency. Now, we have wavelength. Speed of light is always 2.998 times 10 to the 8th power. Therefore, we also know the speed of light, and the unknown quantity is the frequency. If we divide both sides by wavelength, we'll get the frequency by itself. Let's divide both sides by the wavelength. The wavelength on the right side will cancel, and we'll have frequency is equal to c over lambda. However, we know both of these quantities because our c is 2.998 times 10 to the 8th, and wavelength we have from the previous part. Now all we need to do is input this in a calculator. Our answer, if we put it in a calculator, is 3.083 times 10 to the 15th power. Our unit for frequency is always inverse seconds, or you can also say hertz. So when an electron transitions between levels, this is how we find the wavelength and frequency of the photon that gets emitted.